Alright, welcome back to another video. This video is going to be continuing the book. Last video I started a new series. I think it's important to talk about home office stuff, so I started a series for that. But this video is going to be further diving into use case 1. Is there something wrong with the network? Or wrong with my network subscribers. So if that is the case, we'll be able to use AI or machine learning to figure that out. So I think did I read this already? No, I didn't read any of this yet. I remember reading some of it. I'm not sure where I read, but I'll read up to the approach to the input data. I tried preparing my development environment, but that didn't go so well. So let's do some reading and then go back and try to set that up. So pain point. In our network above, I remember reading this because above, what do you mean? There's no icon or anything listed. The provider edge devices are also running as broadband network gateways, BNGs, so they directly provide internet access to subscribers based on their region. Based on that, at any point in time, a certain number of subscribers are active. This number will vary across regions, but also based on time of the day of the week, and potentially other factors such as network authentication issues, etc. Net, the number of subscribers on a BNG, is a metric we are interested in tracking because an anomalous value could mean there is some problem that needs to be investigated. Mic check. Therefore, our pain point here is to evaluate whether the number of subscribers in a certain BNG from our network scenario is usual or not. This metric will evolve, and certain variations are expected. We need to implement some mechanism that can detect anomalies properly. Note that the exact use case could be developed for any other metric of interest, so feel free to find equivalencies in your use case of interest. And you can very much apply the same to any other metric of your choice. So, advance the bookmark here so I don't accidentally reread that. The next section is approach. The approach to this type of problem could be to determine the correct upper and lower threshold for such a metric to determine if the value is normal or not. However, the suitable thresholds may vary over time due to seasonality, for example. Therefore, a static definition of a threshold and comparing the metric value against that threshold is not feasible. We need to implement some mechanism that can learn the normal value or the normal range of values for the metric, and in doing so, identify deviations from the normal as anomalies. And this is the approach we will take to address this pain point. In the example, we will test various algorithms for anomaly detection. We can see how they are configured and how they perform. In particular, we will evaluate simple rolling window and z-score, profit, LSTM based autoencoder. Remember what this stands for. It means long short-term memory. Feed forward dense based encoder. By showing these various methods from straightforward to very complex, I will demonstrate how they can be programmed and trained and how well/badly they perform. I will remember it frequently in use cases, but I am just using these algorithms as examples and not trying to optimize them in any sense. The goal is not so much to resolve this use case optimally, but to show you options and methods. All right, and I'm going to, this is part of the, okay, so I've got, I'm going to put on my headphones. Okay, there we go. So, okay, cool. Input data. Our target metric for this use case is the number of BNG subscribers in one of the devices, in particular PE4, Provider Edge 4. I have configured SANS to generate this metric BNG subscribers for this device in a way that contains daily and weekly seasonality, random anomalies inserted. Specifically for PE4, the following are the device metric generation policies configured in SANS. For BNG subscribers, it means it will be a seasonal metric generated with 3 different patterns, P1, P2, P3. P1, pattern 1. Value will be randomly picked from the range 20K through 21K, 21,000. Uniform distribution during 96% of the time. P2, pattern 2, value will be randomly picked from the range 25K through 26K during 2% of the time. P3, value will be randomly picked from the range 5K through 6K during 2% of the time. Essentially, it means that most of the time, 96%, the metric will be within a range of values conditioned by the seasonality, but in a small percentage of times, the value will be above or below. So, 4% of the time, the value will be either anomalously high or low. Therefore, we are introducing anomalies, and our goal is to build a model that can capture those anomalies. We use SANS to generate the data. We have, however, generated already one sample of it, which is stored in the BNG subscribers metric.csv file. You can choose to generate new data or simply use the existing file. Okay, so we're going to use the existing file. This is the BNG subscribers metric file. Here's an excerpt from it, if not the whole file. So I'll advance the bookmark, and then we'll pull up that file in VS Code. Being comfortable using VS Code is something I recommend for every modern day network engineer, even if you're not coding. Just to get used to manipulating the files, putting commands here, running them one at a time. It's just a tool that a lot of people are using and having a good experience with. So let's open that. Well, you know what? Let's do this. So we've got this forwarded port here. Let's see if it's still open. Okay, so nope, the port is now closed. So let's see if there's an option to reopen the port. No. So once it's dead, it's dead. So we're going to delete the open port there. And now we're going to do Jupyter Notebook. There we go. And open in browser. And now we'll take a look at the file that was mentioned just now. The file is bng-subscribers _ metric.csv. All right, and here we have the file. We can see it's a very large file, 8,000 lines. We can see if we open it in here, we can see the same thing as well. We have a recommended extension here, so I'll install that. Should make the CSV a bit easier to see. Yeah, so now we've got the different fields are a different color, so that's easier to see there. So yeah, let's continue on. So you can choose to generate new data or simply use the existing file. So and then we've got a code excerpt here. I think is this for generating new data? I'm not sure what this is for. We've got time delta, and then time delta is called here. So we've got a time range. So metric _ df. I'm not sure what stands. A data file, maybe data frame, because we're using Sans to get data frames. I don't know what this codecs are for, but I think I'll just ignore it and move on. We are requesting here the sans.generate device metric time range function to generate data for a period of 30 days with 5-minute frequency for device PE4 and specifically for the metric of interest BNG subscribers. You can play with other metrics or other devices or other time frames. Okay, so this is described here. The result will be presented in a data frame. And there we go. So I think if I go to the Jupyter Notebook here, this is actually, so this is a code excerpt. So we should be able to get everything to run here. So let's do restart and clear all output. And let's make sure we've got a virtual environment open. Okay, we do. So now we can run the Jupyter Notebook again. Okay, so restart it. Everything's good. Now we're gonna restart and clear all output. Make sure that everything is good. Oh, so we've got some problems here that we didn't have before, which is kind of interesting because we did run this yesterday, and we got everything to work. So so it looks like NumPy version has to be greater than 1.17 and less than 1.25. So let's see which version of NumPy I do have. Oh, you know what? I meant to say, I meant to do something else. There, that's what I meant to do. Okay, so we've got version 1.26.4. So that is higher than the maximum version that's allowed. So let's try to change that version. We're going to change it to 1. So it has to be less than this version. So let's take a look at what versions of NumPy are available. Okay, so here's all the versions available. So let's go to 1.24.3. Okay, so it's not a valid syntax. So the correct way is you need 2 of these. Okay, so now if we do that same pip freeze command with the grep, we can see we've got a valid version. So let's refresh. We'll just do a full refresh. You don't have to, but I just want to. And then we're going to do a restart and clear all output. All right, and then what we are going to do is we're going to change this to make sure that I don't just blow it away with the wrong version again. All right, and then we'll run this to get to make sure everything's already installed. This one, yep, it's so, okay, see this? So it actually runs in its own environment. This kernel is different from here, so they're not going to match. So it's a good thing I did that, because in this virtual environment, which is like here, you know, this is the kernel for Jupyter. uh, that's a different virtual environment uh, than my local one there, as far as I understand. So, or at the very least, I would have had to stop this and restart it in order to pull back from the virtual environment here. But the fact is, it was at an incompatible version, and now it's at the right version. All right, so on to the next few lines. So here we shouldn't have that error anymore. There we go. That error is gone. Next, we've got this TensorFlow binary is optimized to use available CPU instructions. So this is feature guard to enable the instructions. Rebuild TensorFlow with appropriate compiler flags. We could not find TensorFlow doesn't match a supported version. So we'll go to ChatGPT with this.
It looks like you're encountering a couple of warnings related to TensorFlow and the request library. Here's a breakdown of the issues and potential solutions. TensorFlow CPU optimization warning. This warning indicates that your TensorFlow installation is optimized for CPU performance. However, if you want to enable additional CPU instructions like AVX2 and FMA, you would need to rebuild TensorFlow with the appropriate compiler flags.
All right, and I don't need to have it read it out loud. Yeah, we've got that warning there. So TensorFlow is optimized for CPU performance. That's probably not good because I do have a good GPU on there. Yeah, it's not found. So we need to install TensorFlow RT. You can ignore it if you're not using it, but I guess I might as well have it. All right, so then we've got the warnings. Okay, so we can install these. We'll just add these to the top of the file. Okay, and this is URL lib, which might already be on here. Nope, don't see it. And then this is Cardet, so looks good. So we're going to restart the kernel and clear all output. Yes. And then we're going to run everything once it's looks good. There we go. Looks good there. So now we've got our new ones there. So now here's the moment of truth here. Let's see if we've got some of those warnings reduced. Yeah, so we got that other warning reduced. So we just got these two warnings. It looks like it's just one warning, actually. No, it's two. We can see the timestamp here, so we know we've got one here, and we've got another one there. So we've got two warnings. Let's tackle the first one. So the first one is TensorFlow binary is optimized to use available CPU instructions in performance-critical operations to enable the following instructions. AVX2 FMA. In other operations, rebuild TensorFlow with the appropriate compiler flags. And then in addition to that, we don't have TensorRT. So you know what? Those are probably acceptable. We don't have to have it be perfect. So we do have a clue here from ChatGPT. If we need additional optimizations, we can build from source with specific compiler flags. If we need TensorRT, we can install that. But for now, I think so. I don't think I need TensorRT, and I added those libraries at the specific versions. and I don't think I don't need everything to be perfect. This is just like an educational thing, so I don't need the CPU optimizations created by using compiler flags. So I think I'm good to go. Thank you. Okay. Yep. All right. So let's see here. Okay. So now that this is good, we should be able to get to the point we were in the book where we can see the data frame. Okay, this is kind of a moment of truth. So here we have a problem. Sans has no attribute. So this could be a problem relating to the to here. So what we need to do is check this import statement and check there. So we could do that here. So we're gonna open a Python IPython 3, and then we're gonna do import sans. And already here we've got a problem. No module named sans. So if we do a pwd and then we cd into uc1, okay, now this is the correct place to be because this is where the notebook file is. And we get the same problem. No module named sans. So I'm surprised this didn't show up. Yeah. I'm surprised we're not getting that showing up here. Okay, so now we have it. So it's these statements up here are going to need to change. So if we have the syspath different than here, that should help. So I need to figure out where that syspath needs to be. Okay, so I think we can do that and have the syspath be. See, I'm surprised that this is not a suitable syspath. But let's just do. Let's not append the syspath. And then run the cell, import, and see if we get that data frame. Nope. So same problem. This module does not have that attribute, so we can dive deeper into that. Okay, so now we've got this file, so we can check if it does or indeed does not have that attribute. Okay, so the attribute is this one here. And we can see it does have that attribute. So I don't know why it thinks it doesn't. Obviously, there's some kind of issue. Let's change this. We're gonna have it be from sans, import sans. Let's see if that makes a difference. Okay, so now we've got a problem. No module named sans. You know what we can do is see, the thing is, it's not a let's feed this into ChatGPT. I have a feeling that's going to be like the default. That's like the default thing to do, because this one's really kind of, yeah. We've got sans dot generate there. So we're gonna delete these two, and then put this in here, and then we're gonna give it this. Yeah, we're going to give it like that, and then we're going to come up here and be like that, and we'll feed it this whole screenshot. All right, and that should be enough. All right, so I'm using my new headphones. I don't see them. I don't see them popped up. Hold on a second. This is mode. Oh, this is. I think I have to hit the mode button. All right, so these are new. I don't know how to use them, and I haven't RTFM. Okay, well, I can't use these, so I'll take them off. Oh, here we go. Oh. Oh, okay. Okay, good. Okay. All right, sweet. Okay. There was this bad buzzing in there, but the buzzing's gone. I should get the audio out through here now.
Based on the error message in the provide code snippet, it seems there is an attribute error saying that the module sense does not have an attribute generate underscore device underscore metric underscore time underscore range. However, from the second image, we can see that the function generate underscore device underscore metric underscore time underscore range does indeed exist in the sans app UI file. Here are a few possible reasons and solutions for this issue. Module import issue. Ensure that the sans app UI file is in the same directory as your script or is in Python path. If it is in a different directory, you may need to add that directory to the Python path. Name conflict. Ensure that there is no other file named sans app UI in the directory or in the Python path that might be conflicting with your intended module. File save issue. Sometimes, if the file isn't saved properly, the latest changes might not be available. Make sure you have saved the sans app UI file.
Defining the generate underscore device underscore metric underscore time underscore range function. Module reload. If you have made changes to the sans app UI file after starting your Python session, you might need to reload the module to ensure the changes are picked up. Here is a checklist to debug the issue. Checklist. Verify import path. Ensure the directory containing sans app UI is in the list. Check for name conflicts. Ensure there are no other files named sans app UI in your project directories that might be getting imported instead. Save the file. Make sure the sans app UI file is saved after defining the generate underscore device underscore metric underscore time underscore range function. Reload module. If you have made changes to sans app UI after starting the Python session, reload.
Okay, so unfortunately, it's a disaster. It's using a codec that you would use over phones, and it's got a static interference on it. So this headset, not so good. All right, so based on the error message, oh, you know, we can have it read it. That's fine.
Based on the error message in the provided code snippet, it seems there is an attribute error stating that the module sense does not have an attribute generate underscore device underscore metric underscore time underscore range. However, from the second image, we can see that the function generate underscore device underscore metric underscore time underscore range does indeed exist in the sans.py file. Here are a few possible reasons and solutions for this issue. Module import issue. Ensure that the sans.py file is in the same directory as your script or is in the Python path. If it is in a different directory, you may need to add that directory to the Python path. Name public.
Yeah.
Ensure that there is no other file named sans.py in the directory or in the Python path that might be conflicting with your intended module. File save issue. Sometimes, if the file isn't saved properly, the latest changes might not be available. Make sure you have saved the sans.py file after defining the generate underscore device underscore metric underscore time underscore range function. Module reload. If you have made changes to the sans.py file after starting your Python session, you might need to reload the module to ensure the changes are picked up. Here is a checklist to debug the issue. Checklist. Verify import path. Ensure the directory containing sans.py is in the list. Check for name conflicts. Ensure there are no other files named sans.py in your project directories that might be getting imported instead.
Can you rewrite the checklist so that I can actually like check things off from the list interactively? Oh, that's badass. Whoa, look at this.
Certainly.
Oh,
Here's
it
an interactive checklist
doesn't
you can follow
work
to debug the issue.
though.
Debugging checklist verify import path. Run the following code to print the Python path and ensure the directory containing sans.py is listed. Check for name conflicts. Ensure there are no other files named sans.py in your project directories or anywhere in the Python path.
Ah, it doesn't work. Can you try again? It doesn't work. What I want to happen is like a check mark or an X to show up in the box when I click on it. Like I want to like be able to remember whether or not I've completed the step by clicking on something and having that something change to indicate that I have in fact completed it.
Certainly. Here's a markdown checklist that you can use interactively. This
Okay.
will work if you are using a markdown editor that supports interactive checkboxes such as Jupyter Notebook or certain markdown editors.
Yeah, that's not bad. So all we have to do with that is create a new file and then go down here and change it to Markdown. All right, and then we can take what we're given by ChatGPT. Put it into preview mode. I don't know what happened there. So we've got it here, so we can change this to Markdown. We can paste in what was given to us by ChatGPT. We can open a preview. And then now we should get... nope, never mind. So it doesn't work. Well, that's okay. Someday it'll be able to do that when it grows up. All right, so that's fine. So yeah, it's the statements up here need to change. So let's see if we can add that. Yeah, sysappend back. And we're gonna see. The thing is, like, I thought I had it to sans like that. But then the thing is, what about path files? Where does that show up? Let's take a look. So path files, yeah, that's gonna be over there. Then we have let's see here. So we have let's try that. Huh. Weird. Okay. Well. Huh. So let's do this. Let's do a we'll do it on the top here, and then we'll do a help on the sands module. All right, and then we'll run this one, and then run this one. Okay, so now we've got. Oh, okay, so it looks like what's happening here is So we're pulling in the we're not pulling in the file. So so we need to because you can see we're pulling in sans underscore and so it should be from let's do from sans import star. Okay, and then we'll take a look at sans dot. Okay, and then we should be able to remove the sans dot, and it should work then. Hopefully, that's the idea, anyways. And we can get rid of the help. Weird. How is it able to? It's definitely defined. What if we do a sans dot like this? Okay. So we know what's happening. What's happening is that it's importing oh, really? Is it? How is it doing that? Weird. Why is it not Huh. Okay. Well, I'm kind of confused here. So yeah. So ChatGPT's got me a big debugging list. So yeah, this is a big one. Before we alter the path, we should see what the current path is. That will help a lot. All right. So there we go. So before we alter the path, let's take a look at what the path is. Then we're gonna alter the path, and we'll take a look at what the path becomes. Okay, so before we alter it, we see the syspath is here. So we've got UC1. Okay, and now we alter it again. So I think this is how I fix it. So if I do a Control C twice, and then I close this annoying pop-up window, and I do a PWD. Okay, well that's interesting because I'm in there. So like somehow, okay, so that wasn't it. All right, so we'll restart and clear all output, and then we'll run this, run that. Now we'll get the before and the after so we can see. Okay. So I think I got it now. I think I got it. So what we can do is go like this. Okay, so we've got the same thing. Sans is not defined. That's because I didn't change this statement yet. Okay, now we've got the same problem. It does not have that. Oh man, what in the world? Why? Oh, it already has it. Maybe I have to put the file there? Like that? Maybe I have to do that? I hope this annoying buzzing isn't coming. Okay, it's not. You can't hear the output. Good. That I'm trying a new pair of headphones, and I think this unfortunately only has a specific codec, so that's bad because it creates a buzzing, which is bad, and then it's as if I'm on the phone. It sounds like I'm on a landline, basically. All right, looks good to me. Now we can import. Okay, and should work now. Same problem. Okay. Okay, so let's go through the rest of our checklist. So we've got our name conflicts, done that. The file is saved. So now we can reload the module. Changes you made. Just starting. So let's try that. All right, and that didn't work. So the next one, print all attributes of the module. So that'd be a good one. All right, so yeah, we see sure enough, as sure as the S word, as sure as rain and snow, we don't have this there, which I mean it makes sense because it's not a class, right? It has to be a class with methods in order to have that. All right, so let's create a new cell above, and then let's let's undo that by clicking this down arrow, and now let's click this button here. So insert cell below. We're gonna do that below all these imports, and then we're gonna put in this debugging script, and then kernel restart and clear all output. There we go. And now go back and run everything one by one. And you can see if it's been run because this changes. If it's working, it changes into an asterisk. And if it finishes working, it changes into the number of the line of code that it ran. So this was the second line of code. And we see it's finished that because it's named with a 2. So we're going to run another line of code here to import everything. So we can see it's still working on that, and now it's finished. And then we'll run our test script. Okay, so the test script failed. So let's take a look at what ChatGPT has to say about that.
From the error message import error, cannot import name, generate underscore device underscore metric underscore time underscore range, from sans, it appears that Python is not finding the function generate underscore device underscore metric underscore time underscore range in the sans module. This can happen if sans is being imported from a location that does not contain the function you define. Steps to debug here are detailed steps to debug this issue. Verify the module path. Ensure that the sans module you are importing is indeed the one that contains your function. You can do this by printing the path of the module. Check for name conflicts. Ensure there are no other files named sans.py or directories named sans in your project that might be conflicting with your intended module. Ensure the function is defined. Make sure that the generate underscore device underscore metric underscore time underscore range function is correctly defined in the sans.py file and that the file is saved. Update imports. Check if the sans.py file is in the same directory as your script. If not, make sure to adjust the import path accordingly. If sans.py is in a subdirectory, you may need to use a relative import.
Yeah, so
Example code to print module path and check function existence example code.
I can see what the problem is. Okay, so I can see what the problem is it is taking this module from site packages, and instead I need it to be installed from my local repo, or I guess another solution would be if the site package properly populates with all of the functions that I need. I think a part of the reason this is a problem is because it can't populate as a site package if all you have are functions in the file and you don't have any classes. Would I be correct in making that claim? I think that could be a solution, is to just have this file being written differently so that all of these methods are contained within classes. But I think a better solution, especially short term, now that this is just an educational exercise and not like a real product, is to draw it in rather than from site packages under .local lib Python 3.10 site packages. Rather than drawing it from there, drawing it from the place it exists in the actual repo I'm working in. So it exists under a directory named sands, all in uppercase, and the file is sands.py, all in lowercase. So if I can just draw the file from there to import that file rather than import a site package, that will solve this problem. So how do I do that?
To import the sans.py file directly from your local repository rather than from the installed site packages, you can modify the SYS path to include the directory where your sans.py file resides.
Well, that didn't work.
This way, you ensure Python uses the local file rather than the one installed in the site packages. Here are the steps to achieve this. Determine the path of the local file. Identify the full path of the directory containing your sans.py file. For example, if the file is located in home, user, project, sans, that is the path you need to add to SYS path. Modify SYS path. Add the directory to SYS path at the beginning of your script. This ensures Python will look in that directory first when importing the sans module. Import the module. After modifying SYS path, import the sans module as usual.
Oh, I see.
Here's an example script demonstrating these steps. Example script explanation.
Okay, I totally understand what is happening now. I was confused because I did have that sys.path.append statement in it, but now I understand because it's a list and I appended it to the end of the list, and it just goes through the beginning to the end one by one until it finds it. So it looks in that dist-packages before it looks in the local repo. So that was my problem, is I need it to look there first, and that's not going to happen if I append it to the end of the syspath list, since it will look through the list from beginning to end. And then it will go with the first match it sees, and it will not check any of the other ones. Is this correct?
Yes, you're correct. When you append a path to the end of the SYS path list, Python searches through the list from beginning to end and stops at the first match it finds.
Yeah, okay.
This means
Well,
if a
that's
module with
easy.
the same name exists in the directory earlier in the list, Python will import that module instead of the one you appended. To ensure that Python searches your local directory first, you need to insert the path at the beginning of the SYS path list. Here's how you can do that. Correcting the path order instead of appending the path, insert it at the beginning of the SYS path list. This ensures Python will look in your local directory before any other paths.
Okay. So,
Example code explanation.
yeah, so now we can see it's now at the beginning. So that's the first one it's going to see. It's going to find it there, so it's going to stop and not look any further. So run that cell. So let's, we've got the cells running out of order here. So let's restart and clear it all. All right, and now the cells can run in order. And we're still printing out those syspaths, which is nice. And we can see now we appended it. Now we inserted it in the very beginning. So we won't have these issues anymore. Hopefully. So we got that error again. TensorFlow isn't set up exactly perfect. Don't care. RT is not set up at all. Don't care. And here's the moment of truth. Same problem, and we can see we've got the same issue where it took it from the site packages rather than locally, even though we can see the syspath has been modified correctly. So What? We also see something kind of odd here. It looks like it was added twice. I don't think that will make a difference, but nothing in the code I think says to add it twice. So it just kind of did that for some reason. Oh, you know what? It was already there. What? You know what? Let's take this and make sure it's running in the correct order. So we're gonna do a look at that a cell above. So we're going to hit this, create another cell below, click. Yep. So paste that, and now we'll run all the installs. We'll run this and take a look at what the path is. So yeah, we don't have that there already. It just doesn't exist at all. So let's go to the next one. And now we have it there. It doesn't show up twice. So there was some kind of problem, I think, because I kept running it. The prior instance of it running was still taking effect, so I kept re-adding it. So I didn't clear it out properly before I ran it the next time. Okay, and same problem here. We're doing it from the site package and not from the other one. So we have to do this correctly. So let's just do this. We're gonna have it be so we can see what it was before. It was US like that. So we're on the right track here. If we insert it like this, I think this might solve the issue here. So there we go. Looks good to me. So then the next step is to come down here and do from all in uppercase, all in lowercase, and restart everything. Now, it would be cool if you could restart and clear output from individual cells. I'm not sure if you can do that. In Jupyter Notebooks, can you restart and clear just for individual cells rather than the entire thing? Ah, dang it.
In Jupyter Notebooks, you cannot restart and clear outputs for...
Well, whatever. Okay, so there we go. We'll get to a moment of truth, and then I will need to take a quick break. So here it is before, and here it is after. We can see we've got the main one here. And then, yep, same thing there. Nothing changed there. And here's the moment of truth. Aha! So made a lot of progress there. We do have a problem with the code here, but I need a quick break, so I'll take that and I'll be right back. All right, I am back and feeling good. So I've got the solution to that. Let's keep reading this book. So let's see here. I would like to... Oh! What? Sorry, I'm trying to... Oh. How do I unconnect it? Shoot, I just got a new headset. Alright, well... Alright, these headphones are not so great. So, we made some progress here. So, let's see what ChatGPT has to say about this. Hopefully, it's an easier problem now. and I don't have it hooked up, unfortunately.
Something seems to have gone wrong.
All right, so that's different. I haven't really seen that one in a while. Something appears to have gone wrong. So I'm going to hook up my Bluetooth. Connect it. Okay. Connected. All right. So something went wrong. So let's do a refresh. Open a new chat and put it in there.
The error message in the screenshot indicates that you are trying to use the append method on a DavFrame object, which is causing an attribute error. The append method is not a valid method for a DavFrame in this context. The error traceback shows the code failing at device_inventory_df append. In recent versions of pandas, the append method for DavFrames has been deprecated.
Oh, okay. Well,
Instead,
can I
you
use
can
an
the
old
concat
version?
function to concatenate DavFrames. Here's how you can modify your code to fix this error. Create a list of DavFrames that you want to.
I mean, why don't I just use an older version? Like, this is just an educational thing from a book. So, like, the book was published in 2023. So, like, it's fairly up to date. But, like, I don't know how much development Pandas gets. So, like, why don't, or, like, maybe the author is, like, using an older version. So, like, what is the latest version of Pandas where that append method is actually valid? I'll just use that instead.
The append method in pandas was deprecated in version 1.4. If you want to use the append method as described in your educational materials, you should use pandas version 1.3.5 or earlier. Pandas, pandas, data, scientist.
And I'm doing a sound check.
Pandas 1.3.5. This will allow you to use the append method as shown in your book. However, it's recommended to get familiar with the concat method as it is more flexible and the preferred method in newer versions of pandas.
Yeah, okay, good.
For example, using concat, this approach ensures that your code will be compatible with the latest versions of pandas.
All right, so now we're going to run this. So now we got a different version of Pandas up and running. And we can see why we had that import error, because we were looking in the wrong spot. So we'll modify that in the next cell. So now we're looking in the correct spot. Okay, so now we'll import from our sans directory. We'll import that sans file now rather than from site packages. And this is just a variable we'll need for later. And here we can see what file it imported, what file this belonged to, this module that we imported. And now we've got the data frame. So now we're back up to date with the book. Oops, and this is not finished running yet, so we'll have to wait for that. And in fact, this is not finished running yet either. So all of these frames are still running. So let's click one more, and we might as well wait for this one to run too. And once we can see the output, which should look just like this, then we can move on and keep reading. All right, so it's taking quite a while. I don't know why it's taking so long. We could probably get some, so we can get some time-stamped messages here. So the earliest one we got was from 2 minutes ago. We can't find TensorRT. That's fine. That's from running that other cell. Other than that, I don't see anything else. Okay, so now we've got these going now. So so I think we got the wrong. So no such file or directory. I think we have to put the full path. I think that's the problem. All right, so now let's restart and clear all, and hopefully that will be that. All right, so we'll wait for this to run. That one takes about a full minute, from what I understand. We can put a timer on it. See how long it takes. So still taking quite a bit. We're at 20 seconds. All right, past 30 seconds and it's still running. I think it takes at least a minute. And we're almost at the minute mark. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So it's taken well over a minute so far. And there we go. Now we can see it's done. So it takes about a minute, minute 15. I started the clock late. So, all right, next cell goes right away. Next cell right away. And here's the moment of truth. We've got the data back. Everything ran well. For each row in the data, we've got everything. Yeah, so perfect. All right, so let's take a look at some of the values, see if they're different. So we've got the IP addresses are all 224, so let's see if that's the same. Yep, so they're all 224. Let's take a look at the timestamp. So it ends in 2134. That probably should be different. Yeah, so that's different because we're doing that at different times. And then let's look at the hardware. It ends in 888 for each of them. Yep. The BNG subscribers is different. So yeah, we did it. Perfect. All right, so moving on. The table contains more information than we need for now. It has multiple columns with metadata associated with the device for which we are generating this metric. This information will be useful in other use cases as input features for further analysis. For now, we will be focusing only on the timestamp and BNG subscribers columns. It is always important to understand how our data looks. We can do a simple visualization of our metric and we can observe the seasonal components as well as we can see some of the anomalies introduced. All right, so let's hit that other cell and we'll use Seaborn to get a graph of the seasonality. And we can see here, this is oh. Well, these are days. So yeah. So we can see daytime, nighttime, daytime, nighttime. Yeah. There's a lot less traffic at nighttime. All right. So moment of truth. Okay, and this one's done. So let's hit the next one. Okay. So now let's see how the data looks. And there we go. We got the same thing with we've got the dates here, so we can see it's every day. So yeah, daytime, there's more traffic in the day than there is during the night. And we know that this spike corresponds to the day and this spike corresponds to the night because each of these are when the day changes. So the day changes at midnight. So all throughout here is the 21st. So the 22nd happens at midnight. So sure enough, this is the night, and then all throughout here is the I think so. Yeah, this starts here. So this will be midnight, and then this will be midnight for the other day. So we can see at midnight it's dead. There's like no traffic. And then during the day it increases, and then during the night to midnight the other day. Then it falls. People who start going to bed and they stop using the internet. Hopefully. Some of them do. Not all of them. We do have a few diehards there. All right, so yep. So let's keep going. The next one is problem resolution. Our first approach will be to estimate the normal values by identifying what the expected value is for the number of subscribers and then computing a range, values above and below the expected value, that we find as the acceptable one. In this first simple approach, we will look back at the recent history of the metric and use the past 12 observations. 12 times 5 equals 60 minutes. Sometimes you can estimate a rolling average. The challenge is that the average is more sensitive to outliers and anomalies, and since we have not removed them yet, we do not want our estimation to be impacted by them, or at least we want to minimize the impact. For this reason, we will use another statistic, the median, less sensitive to outlier values. Therefore, we will compute a rolling median and will estimate what could be the range above and below such a value. For that, we will use another statistic, the standard deviation during rolling windows, as a way to estimate how much the value is oscillating and therefore estimate the acceptable deviation from the median. So here's the next cell in the code. Let's go ahead and run that. So it's actually split up into multiple cells. So we've got, we're going to do this mathematics here, which is a bit beyond me right now. In this first approach, so we're going to get a rolling window and z-score. In this first approach, we will use a rolling window in which we will calculate the median of the values in such window, and then we will evaluate the standard deviation. We will use those to compute what is the normal range of values above and below the median to determine the acceptable operational range for our metric of interest and identify the anomalous values. So there we go again here. So I'm not sure how far down to go. Let's see how far the book went down. So the book went to metric df std. So let's go down that far. So that is here. So that this is as far as it went down. So let's save this for later. Once we have computed the rolling values, then we can compute what is the difference between the metric value and the SMA, simple moving average, in our case median, and normalize it to standard deviations. The z-score approach is usually the following. If the deviation is higher than 3 standard deviations, that means it is an anomaly. We are following such an approach in this example. Depending on the metric, this may need to be fine-tuned or adjusted. There is never an absolute truth about what an anomaly is or is not. It is domain specific. So we've got some more code here. We're going to end at anomaly data frame, defining that. So anomaly data frame starts there. So we got to run these 3 cells. First cell goes through instantly. Second cell instantly, and the final cell. All right, so moving on. We can now plot the metric along with the points that have been identified as anomalous. So this next one ends at plt.title to print out the graph. All right, so we're going to need to run just this cell here. And there we go. Look at how awesome that is. We get the graph. And I'm doing this locally. The author wants it to be done up in the cloud on a Google desktop, but I'm doing it locally. I have a really nice GPU, so I'm going to use it. As you can see, the simple methodology is able to capture some of those anomalies. Why other anomalies are not captured probably depends on fine-tuning the different thresholds, rolling window size, z-score threshold. However, we can see how a simple method like the one implemented can automatically capture a good number of anomalies. The fact that we have used the standard deviation is causing us some trouble because the standard deviation is also very sensible to the anomalies themselves. If we visualize the metric along with the computed ranges above and below based on the standard deviation approach, we can see how those ranges also spike after the anomalies happen, and that is not a good sign. So we'll run the next code, so down to PL show, and we'll see how the anomalies spike, which is not a good sign. And before I do that, I will advance the bookmark. All right, so this next one is just all in one cell. So now we can see the anomalies and how they spike. We can see various aspects. The range is highly influenced, as expected, by the anomalies themselves. We can see how right after any anomaly, the range of acceptable values grows significantly because the standard deviation is very sensible to the outlier. Number 2, also as the range tends to increase when the slope of the curve is higher, because given the static rolling window, the variability of the metric is higher when the curve is in a growing or decreasing phase. One alternative to solve some of this would be to use another statistic than the standard deviation to compute the acceptable range of values. Fortunately, it exists and is called the quantile or percentiles. We can compute the acceptable range based on the 95 percentile or 99 percentile of the values, the difference between the median and the actual value in the rolling window. This will implicitly filter out outliers, as those are likely to be beyond such percentile value. When we do that, we obtain the following. So anomaly _2 _df is the final line that will run here in my, so just this one cell here. All right. We can see, and let me go to where I was. Okay, there we go. As you can observe, I'm using another parameter to fine-tune the PCTL multiplier. It helps me fine-tune how far apart the value must be from the median to consider it to be an outlier. The metric has, in general, very low variability other than the impact of the slopes. So sometimes if we do not adjust with a multiplier, we may end up having too many anomalies detected. With the above, we can visualize the results. So we're going to see a graph here. Yep, plt.title is the last line that will run. So just this one cell here. And there you go. We've got the fancy graph. Pretty cool. Running it all on my local hardware. We are now able to detect a few more anomalies than before. It is significant now that the ranges are no longer impacted by the existence of anomalies, but primarily driven by the slope of the curve. Some fine-tuning on the right rolling window may be required to optimize this aspect. As you can see, there is no one-size-fits-all ever in analytics or machine learning. If your data changes, your model or your approach may not work anymore and needs to be revisited. Let's try a more powerful method using Facebook's Profit library. We can take a similar approach and use it to help us estimate what is the expected value. Effectively, it will forecast the next value for the metric at any point in time, given its previous history. Once we do that, we can apply the same technique as before, estimate an acceptable range using quartile deviation, and identify anomalies. The key difference now is that before, we were just using short-term past history, rolling number of samples. Profit has the ability to learn long-term patterns on the signal and identify seasonal components, so it can better adjust what is normal and what is not. Earlier in the notebook, we have created new auxiliary columns in our data frame, DAS and Y, which Prophet needs as an input to work. We create an instance of Prophet, providing our data frame as input. So let's skip ahead to that. Okay, so it's all going to be in the next one. So we'll save this and run it when we want to see the graph. Next, we request the model to generate a new data frame that will be used to predict future values. In that request, we provide as parameters how many new periods in the future we want to generate, 300 in our example, and what is the frequency time we need the new data points to be associated with. In our case is in minutes. So here we go, fig equals m.plot, and then that's enough to see the graph. Okay, oh, you know what? Oh, okay, so I was actually far behind. I'm not sure if this is a duplicate. Okay, so I'm a little bit confused here. It looks like there's duplicate code in here. I don't know if that's my mistake or what the deal is. But, yeah, it looks like I've got some duplicate code in here. But that's fine. Everything worked. So let's move down to the Prophet section and catch up. So in this section, we will by applying, so there's a typo there. It should say we will be applying Facebook's Prophet library to detect anomalies on the BNG_subscribers metric. So here we go. We're calling in Prophet. We're instantiating the class. Then we're defining our variables. So we can see the instantiation of the class here started and stopped. And we can see the number filled in, so it's no longer working. So now we need to define some variables. And now, there we go. So we did a m.plot on that, and looks very similar to what we got in the book. The diagram generated displays the actual values, black dots, the forecasted values, blue line, and the confidence regions, light blue shaded areas. Some quick things to note. Prophet is predicting negative values, which of course does not make sense. But the model has no way to know whether the metric has certain logical boundaries. Also, something we can quickly observe is that the model has learnt the seasonality components as the forecasted values for the different days of the week, more significant in the weekend days, varies and is consistent across the seasonal periods. Prophet can decompose the metric in its trend and seasonal components. So here's the next part. We're just going to run that one line and see these graphs. And there we go. Prophet automatically provides in the resulting data frame FCST columns that contain the forecasted value, YHAT, as well as the identified upper and lower boundaries, YHAT_upper and YHAT_lower, which we can see, right? I actually don't see that anywhere. What if I run this next cell? Okay, well that's okay. I'm ahead of myself now. We will merge all into a new data frame we will call combined results. If we visualize the outcome of applying Prophet to identify anomalies, the results look like the following. All right. So I'm not sure. So what line? So it ran data equals combined. So let's see if I have that line there. Okay, well let's okay, so we've got the combined results. So we'll run this one as well. This one as well. Let's just run all of them and then go back and look at it as we need to. Okay, so this looks like kind of where we're at. The dots are the actual values of our BNG subscribers metric. Blue color dots are those identified as okay, and oranges are those identified as anomalous. The solid black line is the forecasted values by profit. As we can observe, the forecast is minimally influenced by the existence or not of anomalies. It is the result of a mathematical model, part of which involves detecting the components of it, trend, and seasonalities. While it captures quite well the overall behavior, it usually either falls short of the upper range or goes too low in the lower range into negative values. As a consequence, anything beyond that is considered anomalous. So while it is detecting the real anomalies quite well, there are areas with lots of anomalies detected because the model is not able to capture the variations of the metric. Now let's add a new degree of complexity. Let's try neural networks for this problem. We will start exploring how well an LSTM-based autoencoder can learn the behavior of our metric and ultimately help detect anomalies. Let's remember from earlier sections in the book what an autoencoder is. An autoencoder is an encoder/decoder neural network architecture intended to force the output to generate the same value as the input, but doing it by forcing the data to be encoded in a latent space. This is intended to capture and learn the knowledge of the signal and be able to reconstruct it with the decoder. So a great ChatGPT example was, let's say you're at a party, it's a costume party, somebody calls you and says, I want to go to this party, but I don't know anything about it. What kind of party is it? You say it's a costume party, that's a latent space. It encodes what you see in the party, and then you pass it on to the decoder, the person on the other line, and they show up wearing a costume. Because of that latent space, the phone call where you encoded the type of party based on the data you received, the people, what they were wearing. If the training is successful, the reconstruction error should be small when the signal behaves as expected. However, if there is anomalous behavior, the reconstruction error will be larger, which will be an indicator that there is such anomaly. The intent, therefore, with our neural network will be to predict the same values. We will select sequences of a certain length, time_steps, and will generate our training data using a rolling window of such length. Each sequence will be an input observation for the model, and the expected output will be the same input vector. Out of all our data, we will use 95% of the data as training and 5% as test or validation. The reason why I'm producing a larger percent for training is because in this particular test, we do not have that many observations, only around 8,600. And since I'm going to use a neural network, there is a high risk that we overfit if we do not have enough data. Let's give it a try and see what it results in. So this next one will go to test size. So let's see if we're there. Yeah, so let's get down to, so we're in the LTM-based autoencoding section. We will start exploring the possibility to detect anomalies using neural networks and deep learning. In particular, in this case, we will start with using a sequence-based autoencoder. The sequence-based aspect results in the approach of using LSTM. LSTM is well built for sequences, so the intuition says that it may be a good choice. However, it has been reported that LSTM does not work specifically well with autoregressive signals. So we will need to check how well in performs in our case. And in is a typo, it's meant to say it. All right, so the scalar stuff we'll save for later. As I mentioned in the theory section of the book, many ML models require data values to be within a specific scale. In particular, neural networks will work much better if data is between 0 and 1 or -1 and 1. For that purpose, we will use a scalar function that will rescale out data. And I think it's meant to say R there, but we can then use the inverse transformation at the end to bring the results back to the original scale. All right, so we're going to stop at the metric DF. Metric DF. So there we go. Run this one. And yep, so metric df.yscale.shape. Let's see if they ran that yet. Nope, not yet. Next, we have to extract and present the data in the form factor the neural network needs for training. And this one is a matrix representation where each row is one observation. If each observation is just a vector, then we would have a 2D matrix, but each observation might actually be a matrix itself. For example, when data are images. So our matrix can ultimately have multiple dimensions. In our example, each observation is a vector of length time_steps. We are going to generate such an X matrix by extracting vectors from our original data frame. Note that we are both extracting X, the input data, as well as Y, the labels. In this case, X corresponds to the rolling time_steps window of values, and Y corresponds to the next value in the metric after such a window. Note, though, when we get to the training, that we will not be using Y. We will only use X for training. All right, so down to the Y equals NP array. Note the sizes of the generated arrays. So let's generate that and then note the sizes. Okay, so this one is working quite a bit. There we go. And there we go. Shape there. Shape there. And let's see what the last... Okay, so Y equals NP. So we actually got a bit ahead. Next, we will split the training and testing. Usually, more complex methods for splitting are used that ensure statistical homogeneity and balanced classes between training and testing. In our example, as we are working with sequences, we will simply do a time split. So I think I did that already. Let's take a look. Oh, nope, this is the one. There we go. We are going to use the following model. It is not optimized in any sense, and it is not even necessarily a good model. The intent is to show you more how to build and train a model like this. So model.compile is the final one. So we'll do that. Model.compile. All right, and now we got a bit of a problem here. So we cannot open a file to read. Your kernel may have been built without NUMA support, and I don't doubt that is the case because I kind of didn't know what I was doing when I built it. So, all right, so let's see what ChatGPT has to say about this. The answers are surprisingly good.
The error message in the screenshot indicates a few issues related to the execution environment for your Keras model, specifically with CUDA and possibly the GPU setup. Analysis of the error messages. NUMA support warning. This warning suggests that the kernel you are using might not support non-uniform memory access, NUMA. While this is generally a performance optimization and not critical for many machine learning tasks, it might affect performance on systems with multiple CPU sockets or complex memory hierarchies. GPU libraries issue. This indicates that TensorFlow is having trouble loading some GPU-related libraries. This often happens if CUDA and CUDNN are not installed correctly or if their paths are not properly set. Input shape warning. This warning is more about Keras usage and suggests that you should use an input layer to define the shape of the input when using a sequential model. Steps to resolve these issues. 1. Check CUDA and CUDNN installation. Ensure that you have the correct versions of CUDA and CUDNN installed and that TensorFlow is compatible with these versions. Follow the official TensorFlow GPU installation guide. TensorFlow GPU support TensorFlow. 2. Verify environment variables. Make sure the environment variables CUDA_home, LD_library_path, and path include the paths to your CUDA and CUDNN libraries. You can set these in your show profile, basher, ZSHRC, etc. 3. Update Keras model definition. Instead of passing input_shape directly to the first layer in a sequential model, use the input layer. Here's how you can update your model. Additional recommendations. NUMA support. If you need NUMA support and it's not built into your kernel, consider recompiling the kernel with NUMA support enabled, or use a precompiled kernel that includes NUMA support.
Cool.
GPU.
So ChatGPT actually gave me a workaround. It said that I can change some of the code. So I can change this here to say input rather than how it is in the book where it said something other than input. So it model.add keras.layers. So now instead of that, it's going to be model.add input. So that's pretty cool. We got the same result. We'll see how they differ as I continue reading here. Next, we will split the training and testing. Usually more complex methods for splitting. Okay, and I read that already. Yeah, so I think I read. So, okay. We are going to use the following model. It is not optimized in any sense. It is not even necessarily a good model. The intent is to show you more how to build and train a model like this. All right, so model.compile. We are using TensorFlow Keras API and specifically the sequential API. There is another alternative API called the functional API. While the functional is more powerful and flexible because it allows you to build more complex architectures, for now in my examples, I will be using the sequential API where layers are added one on top of another in the model sequentiality. There are multiple types of layers. In our case, we will use LSTM as a recurrent layer, dropout to enable on the previous layer dropout regularization, as we have seen in the theory. It helps the model to generalize better. Repeat vector, simply used to take an input vector and repeat it a number of times. I will explain later that in more detail. Time distributed. It forces an instantiation of time separated instances of the model that is referred inside. Dense or feed forward model, typically required as the last few layers in any neural network, whether it is truly feed forward network or a CNN, RNN, or CNN is listed twice. We remember that these stand for convolutional neural network, for recurrent neural network, and I don't know why it's listed twice. I don't remember there being two kinds of CNN neural networks. So maybe they meant to say GAN. This is a good one for ChatGPT. I guarantee you ChatGPT will know this. So in the screenshot, can you guess why CNN is listed twice? In my opinion, I think it's a typo, but I'm trying to think of what the correction to this typo would be. Do you think it would be GAN?
The text in the screenshot you provided does not seem to mention CNN's convolutional neural networks twice.
Oh, it doesn't?
It focuses on the sequential API and mentions two types of layers used in the examples, LSTM and
Oh,
Yarhouse.
sorry. Sorry, my screenshot was messed up. I'll try it again. Just a moment here.
Sure, please go ahead and upload the corrected screenshot or provide more details. Once I have the correct information, I'll be able to give you a better analysis and suggestion.
Okay, here's the correct screenshot. Sorry. Yeah.
In the provided screenshot, the term CNN, convolutional neural network, appears twice in the description of the dense layer. This repetition is likely a typo. Based on the context, it seems that the intention was to list different types of neural networks where dense layers are commonly used.
Right. GAN.
A more accurate list will include a variety of network types without repetition. Here's a corrected version. In this correction, a second CNN have been removed to avoid repetition, and the list now clearly includes feed-forward networks, CNN, convolutional neural networks, and RNNs,
is there a
recurrent neural
third
networks.
one? Well, I mean, is there a third one?
Given that the context is about different types of neural networks where dense layers are used, we can include a variety of models. Here's an updated version that mentions 3 distinct types of neural networks. This correction includes feed-forward networks, traditional neural networks without any recurrent or convolutional structures.
Okay.
CNN, convolutional neural network, used primarily for image data and spatial relationships. RNN, recurrent neural network, used for sequential data such as time series and natural language. Transformer, a newer type of neural network architecture particularly effective for tasks involving sequential data, like natural language processing, and has largely replaced RNNs in these tasks. Including Transformer provides a modern and relevant addition to the list, reflecting advancements in neural network architectures.
Okay, so I was wrong about GAN belonging there, correct? So is that because these are different types of neural networks where dense layers are used? Was my answer incorrect, GAN, because of this or because it's not a neural network?
Your consideration of GANs, generative adversarial networks, is valid in the context of neural networks, but it may not fit perfectly with the specific examples mentioned for the use of dense layers in the provided text.
Oh.
Let's clarify the distinction in context. Why GAN might not fit, contextual fit. The examples given, feed-forward networks, CNNs, RNNs, are more about types of neural network architectures used for typical tasks like classification, regression, and sequence modeling. GANs, while they are indeed a type of neural network, are more specialized and primarily used for generating new data rather than for tasks where dense layers are traditionally the final layers. Dense layer usage. Dense layers are used in GANs, but often not in the same typical sense as in feed-forward networks, CNNs, and RNNs. In GANs, the architecture is more focused on the generator and discriminator, where convolutional layers often play a critical role. GAN is a neural network. GANs are definitely neural networks. They consist of two neural networks, the generator and the discriminator, that compete against each other. However, their primary function is to generate new, synthetic data that resembles the training data. Correct placement. Dense layers are a critical component in a variety of neural networks. The text aims to list examples where dense layers are used prominently in standard architectures. Here's an example list that fits well with the context. Feed-forward networks, basic neural network architectures where dense layers are the primary building blocks.
Okay.
CNNs, convolutional neural networks, typically used for image data where dense layers often follow convolutional and pooling layers. RNNs, recurrent neural networks, used for sequential data like time series or natural language.
So short answer, in the context of listing where dense layers are typically used, GANs may not be the best fit. A better fit would be a feed-forward network, and Transformer would be a good fit as well. Those are the most up-to-date versions. So Transformer seems like a great fit. Also, feed-forward networks seem like a great fit. Regarding Transformers, this book was published in 2023. So is this book like too old to include Transformers?
The book being published in 2023 is reason enough to include Transformers, as they have been a significant part of the neural network landscape for several years. The Transformer architecture was introduced in 2017 with the paper, Attention is All You Need, by Vaswani et al., and it has since become foundational in natural language processing and other sequential tasks. By 2023, Transformers are well established and widely used, so it's reasonable for modern educational materials to cover them. Including Transformers in the list of neural networks where dense layers are used is both accurate and relevant. Transformers utilize dense layers extensively, particularly in the feed-forward components of their architecture. Here's the updated list again for clarity. In summary, the inclusion of Transformers in the book should be expected given their prominence in the field by 2023. If the book does not mention them, it might be an oversight, but given the timeline, it's appropriate to include them in discussions of modern neural network architectures.
Okay, so wow, that's kind of cool. It's been around for a long time. All right, so yeah, we've got that. This is certainly a typo in the context of dense layers of dense in the context of a dense type of layer. Oh, you know what? It does have a feed-forward network listed there, but CNN listed twice is just a typo. And there's really not much else you can list there. You can list your transformers there, but everything is listed. So it's not really that big of a typo because it's just listed twice. It's easy to catch. The following diagram captures the network structure we have configured. So I like just plugging the diagrams into ChatGPT because I feel like it helps me understand them and not just kind of gloss over them and not spend any time on them. So I like to give each diagram a few minutes by having a conversation about it with ChatGPT.
It encapsulates the encoded information of the input sequence. Decoder. Repeat vector layer. The latent vector is repeated to match the sequence length, 72 in this case. This layer transforms the latent vector from 128 times 1128
Right,
times.
It didn't start on time, so we'll do it
The
again.
provided diagram represents an encoder-decoder architecture commonly used in sequence-to-sequence models, particularly in applications such as time series forecasting, machine translation, and other sequential data tasks. Let's break down the components and flow of this architecture. Encoder, input matrix. The input matrix has dimensions n times 72 times 1n times 72 times 1n times 72 times 1, where n is the number of observations, 72 is the sequence length, and 1 represents the feature dimension, univariate time series. An individual input vector, one observation, has dimensions 72 times 172 times 172 times 1. LSTM layers. The encoder consists of multiple LSTM layers. These layers process the input sequence and compress the information into a fixed-size latent vector, context vector. Only the last LSTM module returns the output with return_sequences equals false, ensuring that the output is a single vector of size 128, latent vector. Latent vector. The latent vector is the output of the encoder and serves as the input to the decoder. It encapsulates the encoded information of the input sequence. Decoder. Repeat vector layer. The latent vector is repeated to match the sequence length, 72 in this case. This layer transforms the latent vector from 128 times 1128 times 1128 times 1 to 72 times 12,872 times 12,872 times 128. LSTM layers. The repeated latent vector is processed by a stack of LSTM layers in the decoder. These layers generate a sequence output that corresponds to the input sequence length. Time-distributed dense layers. The output from the LSTM layers is passed through time-distributed dense layers. Each time-stepped output is processed independently by the dense layer, generating an output vector of size 1, matching the input feature dimension. Output vector. The final output vector has dimensions 1 times 721 times 721 times 72, representing the reconstructed sequence. Summary. This encoder-decoder architecture with LSTM layers is well suited for tasks requiring sequence-to-sequence modeling. The encoder compresses the input sequence into a latent vector, and the decoder reconstructs the output sequence from this latent vector. The time-distributed dense layers ensure that each time-stepped output is generated independently, maintaining the sequence structure. This architecture effectively captures temporal dependencies and is widely used in various applications requiring sequential data processing.
All right, so yeah, it kind of doesn't make it any more clear, but all right, so moving on from that. The encoder receives observations from the training data as 1 times 72 vectors. The encoder is built with a first layer using LSTM with 128 nodes each. Because the length of the input sequence is 72, the system will instantiate 72 LSTM nodes connected in series as per the time-based sequence. Note that only the last one will produce an output and that other layers will consume. This is controlled by... Note that only the last one will produce an output that other layers will consume. This is controlled by the parameter return_sequences equals false. If we wanted to add more LSTM layers to the encoder, we would need all but the last layer to have configured return_sequences equals true, so that each LSTM can feed the corresponding one on the next layer, as we do in the decoder. The encoder offers data in the latent vector to the decoder. In this case, the latent vector is a 128 times 1 vector. We have a repeat vector layer, which basically will force a repetition of the same vector, in this case 72 times, so that the next layer, the LSTM one, can receive each one copy of this vector as input. As a last step, because we have configured return_sequences equals true, each LSTM later, L-A-T-E-R, and it's a typo, it's meant to say layer, L-A-Y-A-L, will make its output available for the next layer. Oh, you know what? Maybe later is correct because it's time distributed. So as a last step, because we have configured return underscore sequences equals true, they'll return them later. So each LSTM later will make its output available for the next layer. Okay, so I think that's not a typo. Which is a set of time distributed dense layers. You can think of the time distributed as equivalent to the repeat vector, but they repeat a dense layer across the time slots, so each time slot will have a small dense network that will produce an output which corresponds to the numeric value in that vector position. The output, as you can see, aligns with the dimensions expected 1 times 72. Why all these values, 128 underscore etc.? Well, just because I chose them. There is no particular reason at this point. They do not work especially well, nor are the optimal ones. Why one layer only in the encoder, and not 2 or 5? That is also part of the trial and error, and that is where AutoML helps by testing multiple combinations. At this point, all we know is that the input and output dimensions are correct. Whether the model works well or will do what we want, it is unknown. TensorFlow has a few commands to get a more visual representation of the model in the notebook itself. So if we do model.summary, which we already did, so we already did model.summary. We can see that here. 1, 2, 3, 4, 5, 6. We got 6 rows in the title row. So 1, 2, 3, 4, 5, 6, 7. He's actually got an extra row there. We've got the total params. Just under 200,000. Let's see what I got. Total params. Yep, this is the same, just under 200,000. So yeah, things really worked out by that correction made by ChatGPT. Thanks, ChatGPT. Okay, so this command gives us information of the output shape after each layer, which is useful for troubleshooting issues. And I'm gonna pull up an image of a neural network, because this is what we're talking about, these layers here. And an even better image to pull up, I think, is probably this one. Because, I think this is more what we're talking about. But we are talking about these hidden layers of the neural network, I think. Okay, so moving on. This command gives us information of the output shape after each layer, which is useful for troubleshooting issues. It also provides information of how many parameters the model has and where they are concentrated. The more parameters, the more complex it will be to train. In this case, the majority are concentrated in the second LSTM layer in the decoder. Very frequently, most of the parameters are concentrated in the last dense layers, but in our example, it is a very simple one, so it contributes minimally to the model complexity. The next command also gives us a detailed visual representation of the model layers. All right, so advancing the bookmark, and we're going to end with, so it's the tf.keras command. Okay, in here, so there it is. So so we must install that. So let's add a cell and install that before we do anything else. So we're gonna go up here. You know what? Let's just add it in the same cell. So we're gonna go like that. We're gonna do it like this with a exclamation point, or sorry, like that. And then let's move this down to this empty cell here. All right, we'll run this cell again now that it has new contents. And there we go. We may need to restart the kernel to use updated packages. So let's try it without restarting it. So we do have to restart the kernel. Let's restart it. All variables will be lost. So let's restart it and clear all the output. So I'm gonna actually make this be in a more logical place in the code. So I'll cut that, get rid of that, and we're gonna run 44 cells. So that looks good there. So we're gonna save that. We're gonna do a restart and clear all output, and now we'll just run all the way down until we get to cell 44. Okay, so now that we're at the Z section, I'll wait for these other cells to complete. One of the cells we saw takes about a minute and 30 seconds. So you know what? Let's not wait. Let's just keep running the other cells. And I am hearing some music. Oh. Never mind, I'm hearing a plane that's like muffled by my headphones, so it sounded like music for some reason. Okay, so yeah, I think all the way down here, we're still, yeah, so this is the section we're on, is this autoencoder. Yep, so there's that correction we made, or that workaround we did with the input. And then yeah, this is the next one that we want to run. All right, so that one cell takes a good minute and a half to run, so we're still waiting on that. And now that went through, so all the rest of the cells go by pretty fast, and we should be all the way up to cell 40 now, so we can keep going with the other cells. Oops, and now we've got a problem here. The module PyDot does not have yeah. So I've got to install GraphViz. Well, shoot. All right, and I might as well feed it into ChatGPT in case there's anything else I need to do. But I should be fine, hopefully, if all I do is install that missing library.
The error message in your screenshot indicates an attribute error related to the plot_model function from TF, cares, utils. The specific error is module, PyDot, has no attribute, invocation exception. This usually occurs due to an issue with the PyDot installation or compatibility. Steps to resolve. Ensure proper installation of required libraries. Make sure that the PyDot and GraphViz libraries are installed and properly configured. Install PyDot and GraphViz using pip. On some systems, you may also need to install the GraphViz executable. For example, on Ubuntu, verify environment variables. Ensure that the GraphViz executables are in your system's path. You can check this by running. This should display the version of GraphViz installed. If it doesn't, add the path of the GraphViz bin directory to your path environment variable. Fixing the import issue. Sometimes the PyDot installation may not be recognized correctly. Try reinstalling it. Use alternative graph visualization. If the issue persists, consider using py.plus instead of PyDot. Update code. Ensure your code properly imports and uses the required libraries. Here's a simple example. Debugging the specific error. If you continue to encounter the invocation exception error, ensure that there are no conflicting versions of PyDot or GraphViz installed. You might also want to check the specific lines in the error traceback for more detailed debugging information. By following these steps, you should be able to resolve the attribute error and successfully visualize your model using plot_model.
All right, so now I've got to run all of them again. This one is the one that takes a minute, so we'll just keep running the other cells. while we wait for that one to complete. And hopefully the issue will resolve just by importing that other module, GraphViz, I think it was called. I don't even remember. But we were all the way down to the auto encoder. Yeah, to this part. I think we were even beyond this. So let me check where I was. So I was under tf.keras.plot. So, yep, way beyond this. Yeah, this is the one here. So we'll wait for it to get there and then reveal the moment of truth. Now, usually I'm only good for an hour on these, but today I'm just feeling it. I'm good for. It's been 2 hours, and I feel like I can go at least I can go longer. So I'm just gonna keep going here until it feels like I can't go anymore. And I don't have all day. I do need to perhaps go and do some other things. All right, there we go. So here's the moment of truth. So same problem here. PyDot has no attribute, invocation exception. And I did install GraphViz, so we know that's not the problem. So let's ask the smartest person on the planet, because ChatGPT is now officially a person.
The error message you are encountering, attribute error, module, PyDot, has no attribute, invocation exception, suggests an issue with the PyDot library. This can be resolved by ensuring that the correct versions of PyDot and related dependencies are installed and configured correctly. Steps to resolve the error: uninstall conflicting packages, uninstall any existing PyDot and GraphViz packages to avoid conflict. Reinstall PyDot and GraphViz, reinstall the necessary packages. Use py.plus instead of PyDot if issues persist. Install the GraphViz executable. Ensure that the GraphViz executable is installed and accessible in your system's path. For example, on Ubuntu, verify the installation, ensure the GraphViz installation is accessible. Run. This should display the version of GraphViz installed. Update your code. Ensure your code correctly imports and uses libraries. Here's an example. Use alternative methods for visualization. If the above steps do not resolve the issue, consider using alternative methods for visualizing your model. You can use model summary to get a textual summary of your model. Example. Final step. Environment variables. Ensure the path environment variable includes the directory where GraphViz is installed. You can add this to your tilde, bashrc or tilde, CSHRC file. By following these steps, you should be able to resolve the attribute error and successfully visualize your model using plot_model.
Okay.
If you continue to encounter issues, double check the versions of your installed packages and ensure there are no conflicts.
All right, so it's a similar issue like we had before with the we had to make sure that it wasn't using the version of the module that was in site packages, and rather the version that was in the repository code. So this looks like a similar problem here. PyDot has no attribute invocation exception. So let's take a look at what we got here. So we don't have PyDot in here, so we need to figure out where it's getting this PyDot. So we can do a similar troubleshooting steps as before, and we'll do the underscore file. So we'll do a control F, and we'll do search for dunder file. So it's sans.dunder file. So we can do a similar print statement here. Down in our, if we can do a search, we know that it's 45, so we can skip down there by doing this 45, or just 45. And we'll get a few false positives, but, well, you know what? That's not working. So let's just scroll down to it. There we go. Pretty easy to find. Oh, and it's because, we don't have a 45. So, okay. So now instead of sans, we're going to do PyDot, and we're going to see what file is actually invoked when we imported it. Okay. So now, PyDot is not defined, which is kind of a fascinating error because it was before, but no, it's not. So the module PyDot has no attribute that, which is kind of interesting because so this is interesting. What? So it's definitely has to do with Keras. So within Keras it uses PyDot. So maybe we need to get rid of PyDot so that it uses it only within the context of Keras. Let's try that. So I'm not going to install PyDot because it seems to be overriding the version of PyDot that I need within Keras. So we'll try that. And then, you know what? Let's just try running all the cells because it will. So we're going to restart and clear the output. And then we'll run all the cells because it will error out at that one cell anyway. Yeah. Okay, and one thing I can do is the cell that we were on, which is here, I can highlight it and it'll be easy to come back to. I can also do this, which will be nice. Find me, like that. And then if I want to find out which cell I was at, I can do find me, like that. And there we go. That's where the cell is. I think you might be able to. So does Jupyter Notebooks have a feature where you can bookmark a cell so that you don't have to constantly like scroll around in your notebook to find out where it was? Oh man, Jupyter Notebooks suck. Okay, you can create a table of contents, which is kind of cool. How do I look at that? How do I look at the table of contents? Oh, you have to install an extension for it? Oh, you can install extensions. Okay, well, that's not that bad. Okay, well, that's not bad. Visual Studio Code has pretty cool features that I use all the time, like bookmarking stuff, but you get it through extensions. So you can add extensions to Jupyter as well. So list out the top 10 must-have extensions for Jupyter and a step-by-step guide to install each of them.
Here are the top 10 must-have Jupyter Notebook extensions, along with a step-by-step guide to install each of them using the Jupyter_contrib_MB extensions package. Top 10 must-have Jupyter Notebook extensions, table of contents, 2 collapsible headings. Code building, execute time, variable inspector, scratchpad, ruler, snippets menu, AutoCAD base, M extensions configurator, installation guide. Step 1, install Jupyter_contrib_MB extensions first. You need to install the Jupyter_contrib_MB extensions package, which provides a collection of useful extensions. Step 2, enable M extensions next. You need to install the MB extensions to your Jupyter configuration and enable the configurator. Step 3, start Jupyter Notebook, start the Jupyter Notebook server. Step 4, access M extensions tab once the Jupyter Notebook server is running. Navigate the M extensions tab to enable the desired extensions. Detailed installation for each extension. Table of contents, 2, navigate the M extensions tab. Find table of contents, 2, in list. Check the box to enable it. Collapsible headings. Navigate the M extensions tab. Find collapsible headings.
Okay, so we've got a problem with the notebook. It's just stalled out. So I'm gonna restart and clear all outputs now. So we can see hopefully the reason why it just stalled out like that. And unfortunately, it's taking a while for it to clear all those outputs. I kind of don't like Jupyter Notebooks. Like, it feels like they don't make things any easier. So give me like the top 10 reason why they're so popular, and tell me like if I don't like them, like tell me the best arguments for why I should change my mind and start to like it.
Jupyter Notebooks have gained immense popularity in the data science and machine learning communities for several reasons. Here are the top 10 reasons why they are so widely used, along with compelling arguments for why you might reconsider their value. Top 10 reasons for the popularity of Jupyter Notebooks. Interactive coding environment. Jupyter Notebooks allow for an interactive coding experience where you can write and execute code in cells, see the output immediately, and make adjustments on the fly. This is particularly useful for iterative processes like data analysis and machine learning model development. Ease of data visualization. Integrating visualizations is seamless in Jupyter Notebooks. Libraries like Matplotlib, Seaborn, and Plotly can render directly within the notebook, providing instant visual feedback. Combine code and narrative. You can mix code with rich text elements like Markdown, allowing you to document your process, explain your code, and present results in a readable format. This makes notebooks excellent for creating tutorials, reports, and documentation. Reproducibility. Notebooks provide an environment where you can share your entire analysis process, from data loading and preprocessing to modeling and evaluation. This ensures that others can reproduce your results. Support for multiple languages. While Jupyter is often associated with Python, it supports many other languages through the use of different kernels, e.g., R, Julia, Scala. This makes it versatile for various types of projects. Collaboration. Notebooks can be shared via platforms like GitHub or Jupyter Hub, facilitating collaboration among team members. Tools like Google Colab take this a step further by providing a cloud-based environment for real-time collaboration. Integration with other tools. Jupyter Notebooks integrate well with various data science tools and frameworks such as TensorFlow, PyTorch, and Pandas, enhancing their utility for complex data science workflows. Ease of use for education. Their interactive nature makes Jupyter Notebooks ideal for educational purposes. They are widely used in MOOCs and university courses to teach programming, data science, and machine learning. Extensibility. The ecosystem of Jupyter Notebook extensions, NB extensions, adds a range of functionalities, from advanced editing features to enhanced visualization capabilities, making it a powerful tool for more advanced users. Rich output. Notebooks can display rich media outputs like images, videos, and interactive widgets. This is particularly useful for demonstrating data visualizations, model predictions, and other dynamic content. Compelling arguments for embracing Jupyter Notebooks. Boost productivity. The ability to write and test code incrementally helps identify and fix bugs faster, streamline workflows, and ultimately increase productivity. Enhanced learning. The interactive nature of notebooks makes them an excellent tool for learning new concepts and experimenting with code. This hands-on approach can deepen understanding and retention of complex topics. Improved collaboration. Sharing and collaborating on Jupyter Notebooks with colleagues of the broader community can lead to better insights, feedback, and knowledge sharing. Seamless data exploration. Notebooks allow for quick data exploration and visualization, making it easier to spot trends, patterns, and anomalies in your data. Documentation and reporting. By integrating narrative text with code, you can create comprehensive and self-contained reports that are easy to understand and share with stakeholders. Reproducible research. Notebooks ensure that your analysis is transparent and reproducible, which is crucial for research and collaborative projects. Real-time feedback. The immediate feedback loop provided by notebooks helps in understanding the impact of code changes instantly, making it easier to experiment and iterate. Versatility. With support for multiple programming languages and integration with various tools, Jupyter Notebooks offer versatility that can accommodate a wide range of projects and workflows. Community and ecosystem. The extensive community support and a rich ecosystem of plugins and extensions mean that Jupyter Notebooks are continually improving and evolving, offering new features and capabilities. Flexibility. Whether you are doing quick data analysis, building complex models, or teaching a class, Jupyter Notebooks provide the flexibility to meet diverse needs. Conclusion. While Jupyter Notebooks may have a learning curve and some limitations, their benefits in terms of interactivity, reproducibility, and collaboration make them a valuable tool in the data science toolkit. By leveraging their strengths, you can enhance your productivity and make your work more engaging and accessible.
Okay, now just briefly give me the top 10 arguments that you wouldn't want to use them.
Here are the top 10 arguments against using Jupyter Notebooks. Version control challenges. Notebooks mix code and output in a single file, making diffs and merges in version control systems like Git more difficult compared to plain script files.
Yeah.
Execution order confusion. The ability to run cells out of order can lead to hidden state issues and bugs that are difficult to track down, as the notebook state depends on the execution order.
That's a big one, too.
Lack of modularity. Notebooks tend to encourage a less modular code structure, making it harder to reuse code and maintain larger projects.
Yes.
Performance issues. Jupyter Notebooks can be slower and more memory intensive than traditional scripts, especially when handling large datasets or complex visualizations.
Exactly.
Scalability. Notebooks are not ideal for production environments where code needs to be scaled, deployed, and maintained over time.
Yeah.
Limited debugging tools. Debugging in Jupyter Notebooks is less robust compared to using integrated development environments, IDEs, with advanced debugging capabilities.
Just use VS Code instead.
Dependency management. Managing dependencies in notebooks can be challenging, leading to issues when sharing notebooks across different environments or with different users. Security risks. Running arbitrary code from shared notebooks can pose security risks, particularly if the source is not trusted. Notebook load. Over time, notebooks can become bloated with excessive outputs and visualizations, making them hard to navigate and slower to load. Professional code standards. Notebooks can encourage quick, experimental coding practices that may not adhere to professional coding standards, making it hard to transition from exploratory data analysis to production quality code. While Jupyter Notebooks offer many benefits for data exploration and prototyping, these challenges can limit their effectiveness to larger, more complex, or production-level projects.
Okay, so I'm back there, and those are compelling arguments for me. Like it states really clearly like what my gripes are with Jupyter Notebooks. So I just want to read that again quick. Version control challenges, that's a big one. They mix code and output in a single file, making diffs and merges in version control systems like Git more difficult compared to plain script files. So I'm like completely sold on version control. It's nice to see a history of your changes. So to get that to have that be more complicated than it already is, it's already very, very complicated, might not be worth it in my opinion. Execution order, that's a big one too. As we saw, you can run your cells out of order, and now you're troubleshooting issues you would not have if you weren't using a Jupyter Notebook. Architecture decisions, it forces you to write your code in less module architectures, making it harder to reuse and maintain for larger projects. And then you're just using this thing, Jupyter Notebooks, and it's just making everything worse. So yeah, I won't read all of them, but okay, now go give me an overview of this sort of thing, like the broader category that a Jupyter Notebook belongs to, and then for each sub item in the category, which will include Jupyter Notebooks themselves, assign a letter grade to the sub item. And then if the broader category is swappable with something else, also assign a letter grade with the broader category and assign letter grades to other such broader categories, assuming that they are interchangeable. If they are not, then just stick to the relevant broader category and do not make comparisons where comparisons are not able to be made accurately.
Overview of interactive computing environments. Jupyter Notebooks belong to the broader category of interactive computing environments.
Right.
These environments provide a user-friendly interface for writing and executing code, visualizing data, and integrating documentation.
Exactly.
This category includes various tools and platforms designed to facilitate data analysis, machine learning, and scientific research.
Mm-hmm.
Subcategories and tools within interactive computing environments. Jupyter Notebooks. Grade A. Strengths. Interactive coding, ease of visualization, combining code with narrative text, reproducibility, multi-language support, rich
Oh,
graphics.
this is interesting.
Weaknesses. Version control issues, execution order confusion, limited debugging tools, performance concerns. Google Colab. Grade A. Strengths. Free GPU access, seamless integration with Google Drive, collaborative features, easy sharing, access to a wide range of pre-installed libraries. Weaknesses. Dependent on internet connection, limited session duration, some restrictions on customization. Apache Dublin. Grade B+. Strengths. Multi-language support, strong integration with big data tools like Apache Spark, extensibility with various interpreters. Weaknesses. Less user-friendly than Jupyter, fewer extensions, not as widely adopted in the community. R Markdown. Grade B. Strengths. Excellent for combining R code with narrative text, powerful for statistical analysis and report generation, easy integration with various R packages. Weaknesses. Primarily focused on R, less support for other languages, steeper learning curve for non-R users. Spider. Scientific Python development environment. Grade B+. Strengths. Integrated development environment tailored for scientific computing, strong debugging tools, variable explorer. Weaknesses. Not as interactive as Jupyter, more traditional light interface, less support for integrating rich text and visualizations within the code environment. VS Code with Jupyter extension. Grade A. Strengths. Combines the power of VS Code with Jupyter's interactivity, strong support for debugging and extensions, versatile coding environment. Weaknesses. Requires setup and configuration, may be less intuitive for beginners compared to Jupyter's native interface. Broader category comparisons. Interactive computing environments versus traditional IDS, traditional integrated development environments. IDEs. Examples. PyCharm, Eclipse, Visual Studio, IntelliJ IDEA. Grade B+. Strengths. Advanced debugging tools, strong support for large-scale software development, integrated version control, robust refactoring capabilities. Weaknesses. Less interactive, more suited for software engineering than data science, steeper learning curve for beginners.
Yeah.
Comparison with interactive computing environments. Interactive computing environments. Grade A. Strengths. Interactivity, ease of data visualization, combination of code and documentation, ideal for exploratory data analysis and prototyping. Weaknesses. Performance and scalability issues, limited debugging tools, version control challenges. Traditional IDEs. Grade B+. Strengths. Robust tools for large-scale development, strong debugging and refactoring capabilities, better for long-term software projects. Weaknesses. Less focus on interactivity and data visualization, higher barrier to entry for non-developers. Summary. Interactive computing environments, including Jupyter Notebooks, Google Colab, and others, excel in scenarios requiring interactivity, rapid prototyping, and data visualization. They are highly suitable for data science, machine learning, and educational purposes.
Okay, so you don't need to hear the rest. The author recommended using Google Colab, and we can see that's a really good choice. That's a choice. Jupyter Notebooks is an A- choice because it depends. Because it doesn't have free GPU access. So the author wants you to use Google Colab because you don't have to have this nice GPU that I have, you can use one for free with your Google Colab notebook. So, okay, so now give me all of the A plus solutions, just anything that would obviously hands down get an A plus. Tell me about that.
Finding an A+ solution depends on the specific requirements and projects, but here are a few top-tier solutions across various domains that are widely recognized for their excellence. 1. Google Colab for data science and machine learning, grade A+.
Right.
Why? Free GPU and TPU access. Google Colab provides free access to powerful GPUs and TPUs, which is available for training complex machine learning models.
Okay.
Seamless integration with Google Drive. Easy to save and load data directly from Google Drive. Collaborative features. Allows real-time collaboration, similar to Google Docs, which is perfect for team projects.
I don't think it's doing that right. It's just relisting them and giving them an A plus, but it's not actually. So I don't think you're doing what I asked. I think what you're doing is just relisting each of them and then assigning them an A plus. I mean, I guess maybe what you're doing is you're making an extra qualification where you're saying what you're using it for. And if you're using it for the appropriate uses, then it gets an A plus. So for example, if you use Google Colab for data science and machine learning, then you're using it in a way that gets an A plus for your systems. But conversely, if you were to use it for Python development, you would not get as high of a grade as if you were using PyCharm instead. So I kind of understand where you're coming from with this. Is that what you were attempting to do?
Thank you for clarifying. Let's approach this by evaluating tools that are widely regarded as top-tier A+ solutions in their respective categories, considering their intended use cases. We'll focus on why these tools excel in their domains and provide relevant grades accordingly.
Oh.
Top A+ solutions by category. 1. Google Colab, A+ for data science and machine learning. Y+, free GPU, TPU access.
See, but the thing is, like, you gave VS Code with Jupyter extension an A- before, right? Like, you didn't give it the same grade as an A+. So, like, why did you just change the grade for that? Like, I guess what I forgot to say is, like, if there are no A+ solutions, just tell me that. Like, obviously, Google Colab is the best choice for the applications I'm using it for, which is machine learning, like learning machine learning, you know, for free and stuff. So obviously Google Colab is the best solution for that, but you gave it an A and not an A plus. So like, if there's just not an A plus solution, let me know about that. But if there is some kind of A plus solution, then I want to know about that.
Thank you for the clarification. I understand now that you're looking for the best possible solutions, A+, in their respective categories, or an acknowledgement if an A+ solution does not exist. Here's a refined evaluation, focusing on whether there are any A+ solutions. Evaluating A+ solutions in interactive computing environments. 1. Google Colab, A+ for data science and machine learning education. Y+, free GPU, TPU access. Perfect for learners and educators without the need for costly
All right. Well, it's I'm overcomplicating it. Okay. So I've got all the answers. So now we have to see we have to troubleshoot that issue. So yeah. So here's the issue. PyDot has no attribute that. We do have PyDot installed. So this is coming from. So are we importing PyDot? So we're not importing PyDot, but we shouldn't have to, right? What if we just import PyDot? Does that do anything? I don't think it will. And this is very costly to just do trial and error here, because there's one command that takes a full minute to run, at least more like in a minute and a half, and that eats up a lot of time. And I think it's this command here. It takes a full minute and a half to run. So let's just run everything down to the subsection here, and then we'll wait to run everything else. And in the meantime, if we can read, let's read. Okay, advance the bookmark at least. All right, and it's starting to hit me. You know, I'm at 2 hours. I'm nowhere near the end of this, so this is kind of a good stopping point for me. So I think what I'm gonna try to do is to get this running, and then that will be that for this video. It's just going on for far too long. We're already almost at the 2.5 hour mark. Okay, so we're down to the next section. Everything ran successfully there. Now, this system of trial and error is not the best because we have to go back and run everything. So, yeah, I'm not sure what a better way to do this is. Okay, so we go down to the find me here. There we go, and we're doing the same thing. So, okay, so PyDot has no attribute invocation exception, but we're not using PyDot. What we're doing is we're calling Keras, and then Keras calls PyDot. So we can see we're interacting with this file here. So let's open that file in VS Code. All right, and then let's take a look at which line errored. So it was 1753. Okay, so now we're calling that, and there was an error with program equals prog. So let's use my I really like the numbered bookmarks extension, which I guess I don't have installed. That's surprising. My favorite extension is not installed. Yeah, my favorite extension is not installed. That's too bad. Fixing that. Yeah, so this is my favorite extension in VS Code. It allows you to drop bookmarks. So we're going to drop one at line 1754. Right here. And then we'll find the next one, which is line 133. Oh, you know what? That was really cool. It actually jumped me down to 133. Yeah, cool. It actually jumped me down to 133. Okay, so here's where this process gets defined. That was called there and had the issue. So then the next thing that happens is on it's a different one. It's the sub process. So we can see, yep, that's just part of these here. So something's happening there in sub process. Okay, now we're in the actual Keras file here. So let's take a look at this in VS Code. All right, and this was on line 37. And we can see it's actually there. Pi dot underscore ng. So we need to get that. So pi and we can see pi dot ng is a fork of pi dot that is better maintained. So if we do a pip install pi dot underscore ng, and we have to spell pi dot correctly here. We have it. So yeah, that's all we got to do. I think is install that. So let's try that, and let's try to install all of them. So we've got pi dot there. We're gonna add pi dot ng, and then we're gonna add pi dot plus as well. All right, and hopefully that solves the issue. I hate to do a trial and error on it. So I can do a find me to find out where I was. There we go. Yeah, so we can see this is where it all stems from. We don't have pi dot. It didn't successfully happen. So dot not found in path. So this is interesting. Line. So this prog here not found in path. This resolved to dot. So let's look at that. And this is on line. This is the core.py file. Back to that, and it's line 1762. And we can jump to where I placed my bookmark and go to 1762, and we can see this prog. Yeah, so program equals prog. Jump up to there. Where's prog defined? Oh, it's statically defined. Okay. All right. Well, let's see if that solved it. All I did was imported some more packages, so hopefully that's all I needed to do. Okay, so I'll wait here until this one that takes so long to complete is finished. So I'm done reading the book, so I can close the book, actually. I just want to get that part to finish, so we're going to spend some time troubleshooting it, and then that will be the end of the video once I get it to work. So this is the unfortunate part, because I have to continue to wait here if I make any changes beforehand. And yep, I made a change. I imported a new module, so I could import it down there and see if that works, but yeah. Okay, So there we go. Ready to go on to the next section. Alright, so here's the cell we're on. Let's see if that made a difference. Yay! Okay, so it did make a difference. But we've got a different kind of error message here. So I must install this. So let's do that. Okay, so we have to sign into GitHub. Let's do it with my Google account. Or now this is not GitHub. That's important to note. This is GitLab. It's a different application that does the same thing. And we don't have this, so let's go to the downloads. And then let's go to the executable packages. So you can see all we have to do is this sudo apt install. And I did that. I'm pretty sure I did that. Yeah, so we have it right here, a graph viz. So I don't know if I need it for Windows because I'm using Wasl or what the deal is with that. But we did get further here. So let's go back to the find me cell. There we go. So we must install this for plot underscore model to work. And the thing is we did install it. So I think the problem was we never imported it after installing it. Nope, that's not the problem. Yeah, because it would have imported it automatically, so that's not the problem at all. The problem is that there's something that went wrong in the installation. It's either because I'm using Windows or I'm using the Windows subsystem for Linux. That could be it. So we can see we've did it correctly here. GRAPHVIZ. That's correct. So I think the problem might be that it's not. It has to be installed for Windows. So let's get the XE downloader for 64-bit of the latest version. And then let's install it for Windows. So prevented and unrecognized app. So let's do more info. Let's do run anyway. I'm going to do yes. And let's add it to the path for all users. I forgot to. I made a shortcut for it. I kind of didn't want to. All right, so hopefully this makes a difference. It looks like I don't have to do a restart or anything like that, which is great. So it's definitely installed in Windows. It's definitely also installed in Linux. I guess we could do another. Yeah, so let's stop the notebook by doing that twice, and then we'll do a. Oh, you know what? I think it was a. Yeah. So we actually needed to do the apt install. So we did a pip install, but that was not enough, I think. So we got it installed in Windows. Let's do the apt install to make sure it's in my Wasl as well. Okay, and now we can open the notebook again. Okay, and open it in the browser. It's already open, so we'll restart it. And then we'll do kernel, restart and clear all output. File saves automatically. All right, and then run. There we go. Okay, so we got that nightmare command that takes forever. So I'll just run everything until the end of the section again. You know what? I can just keep running. It's fine. Okay, I'll run all the way down to the find me cell, and then I'll wait to run that cell, and hopefully everything is good. Ugh. All right, so we're running here. That's perfect. All right, so we're here down to the find me cell. Everything else worked. So moment of truth. Aha! Look at that. So we got it plotted out. Everything's working now. I fixed it. So yeah. That's the end of the video. I guess I'll change. I'll move the find me down, so that I know where I am. That I'm on this cell. And yeah, so that's it. Going on past 2.5 hours, so definitely can't do much more than that. So that's it for the video. Thanks for watching, and see you in the next one.